All right, so chain rule, derivative of the outside, inside stays the same, times the derivative of the inside, right? So as yesterday we looked at, something like this. This is the one of the simpler ones. We looked at as you bring down the 2, you subtract 1, inside stays the same, times the derivative of the inside, which is 6x squared. And how far did we get yesterday?
We got to the repeated.
We got to this one, okay? Did we do this one down here? The 3 to the x?
Yeah.
Okay. Let's try this one. Find somewhere to get us going here. I want you to try this one. Find somewhere on your paper where you got a blank spot and try this one. Try that. See if you can take the derivative of that. What's the first thing you think of when you do a square root? Make it to an fraction exponent, exactly. So my first thought would be that'd be the first thing you do, right? That'd be step 1. This is basically an example that we looked at yesterday of the power chain rule, right? You got some junk to an exponent, so you bring down the exponent, you subtract 1, inside stays the same, times derivative of the junk. So if we do that, we have bring down the 1/2, inside stays the same, subtract 1 times now what we look at today is repeated uses of the chain rule. So now we don't just have an inside and an outside. We got like an outside and then like the next level, and then the next level, and then the next level. You keep working in. Okay, so I'm going to go to the cabbage rule here analogy. So you want to kind of deal with the outside layer first, right? Take the derivative of the outside, inside stays the same. And then you peel back that layer. Then you go to the next layer. Derivative of the outside, inside stays the same. Peel back that layer. Just kind of slowly step your way through the problem, starting on the outside. So let's say we have sine cubed 4x squared minus 3. So we want to find UIDX. So first you want to think, what function is all the way on the outside? That would be the cube, right? So I bring down the 3, subtract 1, now, it may help, I mentioned this the other day, it may help to think of it like that with the parentheses. So now, I brought down the 3, I subtract 1 times, what's the next layer then? I got rid of the cube. The next layer is the sine. Derivative of sine is cosine. Inside stays the same. Times the derivative of the inside, which is it. So we just kind of take it layer by layer by layer until we get an answer. I think the hardest thing with these chain rule ones is we understand the rule. It's just as we do these more and more, it's easy to get confused and mess up and not see what we have. So let's just look at some examples. Cotangent of 4x plus cosine of 3x. And I'm intentionally bouncing around different notation. F prime, dy, dx, just kind of trying to use all of them to get us familiar with. So the first question is, do we remember the derivative of cotangent? Do you remember the derivative of tangent? Secant squared. So the derivative of cotangent is negative cosecant squared. Once again, I don't expect you to know that one necessarily. Sine, cosine, and tangent, we need to remember, but the other ones we don't. Okay, so the derivative of cotangent is negative cosecant squared. So the derivative of the outside, cotangent, is negative cosecant squared. The inside stays the same. Next, times the derivative of the inside. So now we go to the inside. The derivative of 4x is 4. The derivative of cosine of 3x. We have to do chain rule again because we have an inside part there. The derivative of cosine is negative sine. Inside stays the same times the derivative. The key to really doing these is just like step by step. I keep using the analogy, but I like it. Peel off that outside layer, deal with that, and then once you have this, just leave it there and don't worry about it, and then kind of do the next. And if you look at it piece by piece by piece, it can start to look a little ugly, but it makes our life a little easier. Jump to this one. 4x squared times cosine squared of 3x. So I want you just to think, what's going to be your attack? What do you have to do to solve this? Don't actually start it, just think, okay, I'm going to need to do this to try to get the answer. So think about that first, and then we'll break it down. So what's the thoughts as you look at that? Bring the 3 down. Okay. So what would I have? Okay. So there's a first step. And then from there. Okay. This is wrong, so don't write this down. So you got to there, right? What you're thinking. Couple things we gotta, let me rephrase this. Go ahead.
Is the cosine square, is that on the inside of the 4x? No.
So two things. One, you kind of did two things over here, right? One, you tried to bring the 2 down and take the derivative of the cosine. If you bring the 2 down, the inside has to stay the same. Does that make sense? So that would have to stay cosine, right? And then you could multiply by the derivative of that. But even before we get there, we got another problem. Let me rephrase the question. What is the product of 4x squared and cosine squared of 3x? So we're trying to find the derivative of the product of two things. So what do we have to use? Product. So we have the derivative of the first times the second, and then the first times derivative of the second. And when we take derivative of the second, we have to use chain rule. So this is chain rule inside of product. Now, pause the pencils for a second and just look at how you know that. So the important thing to understand when you're doing these is the difference between 4x cubed and like the 3x or the square. Because the 3x is inside of cosine, right? So when you have one thing, and the cosine is inside the square. If I would have written this I don't know, writing it like that helps you to see it. But when you have one function inside of another function, that's chain rule. When you have one thing times another thing, that's product rule. So we want to try to differentiate when is it product rule, something times something, and when is it chain rule on something inside of something else. When functions are inside or they're layered, that's chain rule. So if we're going to use product rule, it is derivative of the first times what? The second. The second doesn't change. Plus the first times derivative of the second. I'm going to pause there. I want you to take the derivative of the second. You try to do the derivative of the second.
You can't bring the 2 down and change it to sign at the same time.
Correct. Because you're working on two different levels, right? Two different layers. You got to deal with the outside layer by itself before you can go to the inside layer. And when you do that, you're kind of doing two layers at the same time. Think you got it?
I don't think it's right.
You have something. First thing we do is we bring down the 2 in front. We subtract 1, which is just 1. Everything else stays the same. Times the derivative of the inside, which the inside is cosine. The derivative is negative sine, but the inside stays the same. Times the derivative of the inside, which is just... There's multiple things as we take these derivatives. Is one, knowing what the product rule is. Derivative of the first times the second plus the first times derivative of the second. Knowing quotient rule. Down D up minus up D down all over down down. Knowing chain rule. Derivative of the outside, inside stays the same, times derivative of the inside. And then it's also recognizing which ones to do. Because in some ways if I say, hey, use the product rule in this one, okay, you know the words of the product rule, right? But the hard part is looking at something and being able to say, oh, I need the product rule, or I need the chain rule, or I need some other thing to solve it. And the only way to do that is just with some more practice. So that's what we're gonna do. Let's just look at some more practice here. All right, let's try that one. Tangent of 2x minus 1 cubed. We're just going to do some practice here. Maybe I'll have. Let me look at this one because this goes into the next one. Okay, so we now have a question on how you want to do this. So if we look at this one here, there's two things we can do. We can think of this as a fraction, do quotient rule, or we could rewrite it like this and use the chain rule. Both work. So I want to show you how that works here. So if I did the quotient rule, the quotient rule is down, D up, minus up, D down, all over, down, down. Now, I also could do this over here with the product rule and the chain rule. It is derivative of the first times the second, derivative of the first times the second, plus the first times derivative of the second, which I bring down the negative 1, subtract 1 times the inside. Now, those don't necessarily look exactly the same, but they are the same because, let me write this over here, and we wouldn't necessarily do this, but I just want to show you this. This is this over here, if you do the negative exponents, is like this. And then imagine here by multiplying by this on the top and bottom. And so you can make that. Can you see how that's the same thing as over here now? So really you can do this two ways. One, quotient rule. Two, chain rule. Same answer. Most people like doing it quotient. They just, right? Sometimes it's easier to do it the chain rule way, right? Maybe it's because of the song, down D up minus up D down, right? You like the song, but sometimes it is easier to do it with chain rule instead of quotient. So as you look at this first one, how would you do it? Try that. With that said, you now maybe have two different ways you could attempt this one. So quotient rule is down, D up. Everybody was good there. All over, down, down. Everybody got that. The second part then is down, D up, minus up. I would have put tangent there. You did it in the other order. That's fine. That is up, D down. Now when we take the derivative of the down, we bring down the 3. We subtract 1. Inside stays the same. Times derivative of the inside, which is 2. Try another one. Try that one. E to the x squared times cosine cubed. You found all of like the derivatives right. You just didn't do the product rule. So derivative of e to the junk is e to the junk times the derivative of the junk, which is the exponent, which is product rule. So it's derivative of the first times the second plus the first times derivative of the second one more parenthesis. And I mean that like you got the derivative of x squared is 2x. You got the derivative of cosine cubed is 3 cosine squared of negative sine x. You got all that right. It was just the product rule of the first and the second and the second and the first that you messed up. Okay. Try some more. So we're just doing, was that the... Did I skip one?
Yeah.
That one? Try that one. More practice. What'd you miss?
Forgot to change it to cosine.
Oh, you didn't do the derivative of the sine.
I put the 2x in with the cosine. So.
Inside the parentheses?
Yeah.
So we're not going to do this one because of time. Let's just think about this one. If you were going to do this one, what is the overarching rule that you'd have to do first? Product rule. And then when you take derivative of the first, would you have to use chain rule?
No.
The first is sine squared. So would you have to use chain rule?
No. Yes.
Because you have to bring down the 2, subtract 1, times, and then the second is tangent of 4x. Would you have to do chain rule for tangent of 4x? Yes, because you have an inside part, which is 4x. So you'd have to do product rule here, and then the derivative of the first and derivative of the second in product rule, you'd also have to use chain rule. Okay. All right, so I'm not here tomorrow, so we're going to review for a quiz on Thursday. 3-4 part 1. Excuse me. Technically, that's not going to be due until next Monday, but I would encourage you to try to finish that one. before the quiz on Thursday, just for more practice. Everything we did today with these multiple chain rule inside a chain rule kind of stuff are not going to be on the quiz. It's going to be, do you understand the basic chain rule? It'll be more kind of like what we did yesterday. Even something like this, where you'd have to do chain rule, derivative of the outside, inside, same thing, but you're not going to have to do chain rule inside of chain rule. Or you're not going to have to do chain rule inside of product rule. You're not going to have those multi-level kind of ones on the quiz. This is going to be very basic. Do you understand, and we'll review tomorrow, but do you understand something like that? That is product rule. Doesn't involve chain rule at all, right? Or that's quotient rule. Doesn't involve chain rule. Or that's chain rule but doesn't involve product or quotient rule. Does that make sense? So this is, do you understand this quiz? The whole idea of this quiz is, do you understand the basic formulas before we go further and we start having things inside of things and make them really hard? So this is, do we understand these basic things? So we'll review tomorrow. Like I said, I will not be here. All the answers will be up on Google Classroom. I'll just going to have the sub give you both worksheets at the start. There's one for in-class, one that's a take-home, as much as you want. We'll come back Thursday. If you have any questions, we can go over those, and then we'll take the quiz, and we'll just do some more practice as we go after that. Okay?